Jai Hind everyone. My name is Ashish Dixit. Today we will discuss about the minimum spanning tree, Prim's and KRUSKAL'S algorithm that will be considered. These are considered in a graph. This topic is considered under the data structure. So again we will start the topic. What is the minimum spanning tree? A minimum spanning tree is a spanning tree such that the total length of its edges is as small as possible. Okay, means a minimum spanning tree is sometimes called a minimum connector, and find out the minimum weight. Okay, then here we will consider some topics. A spanning tree is a subgraph which includes all the vertices and is a tree. Okay, a spanning tree is a subgraph which includes all vertices and is a tree. A subgraph of a Z is a subgraph if a graph is a G and subgraph is a G dash. Then here we will take some examples. A subgraph of G, each of whose vertices belong to G and each of whose edges belong to G. Okay, like here we will take some examples. Suppose that this is the G, this is the G, okay, and we want to take a subgraph A, B, C, D, E. Then A, B, C, D is a subgraph, means a G dash is a subset of G. Okay, this is called the subgraph. Got it? Then again a tree is a connected graph with no cycle, means if tree is create a cycle then it will be graph. If any graph don't have a cycle then it's a tree. Okay, because it's a minimum tree. Suppose that this is the tree, because the tree don't have any cycle. But if we will create a cycle, suppose that if we are connected one vertices to second vertices, then this is create a cycle, then this is the graph. Okay, and if we will remove this, then this is the tree. Okay, next a graph is connected if all its vertices are connected. A graph is connected if all vertices are connected. If two vertices are connected, and if two vertices are connected, if there is a path between them. And what is the path? And what is a path? A path is a walk in which no vertex is visited more than once. Okay, here we will not repeat a path again and again. A walk is a route through graph along edges from one vertex to the next vertex. Okay, these are some concepts. If you face any confusion, then comment in a box. Okay, next. So here we will come on the topic Kruskal algorithm. What is a Kruskal algorithm? Kruskal algorithm is a sometimes called a greedy algorithm because it gobbles up the best least weight arcs. First, it considers the arc, not the vertices. Here, we will work on the arcs. Arcs means edges, okay? Not work on the vertices. So, here is a main concept and main algorithm. Kruskal algorithm sort all the arcs into the ascending order. Sort all the arcs in the ascending order of the weight. Second point, select the arc of least weight to start the tree. Third point, consider the next arc of least weight. And if we select the least weight, then here three conditions will be applied. First, maybe arc will be create a cycle. If arc will be create a cycle, then this arc will be not considered. Second thing, if it's not create a cycle, then it will be considered. If the arc have the same weight, then first of all, we will consider in each turn, okay. Then fourth point, repeat steps 3 until all vertices are connected. Means what is the uses of minimum spanning tree in real scenario, in real application? Then we are use the minimum spanning tree in a cluster analysis and real-time face tracking and a verification system, means locating human face in a video streaming. Then protocols in a computer science to avoid a network cycles, entropy based image registration, max bottleneck paths, and dithering, adding white noise to a digital recording in order to reduce the distortion. These minimum spanning tree algorithms also uses these types of following application, okay. So here we will take the examples. This is a graph that all edges have the weight. This is the graph where all edges have the weight, also called arc, okay. So again, first point of the Kruskal algorithm, sort all the arcs into ascending order of the weight, okay. According to weight, we will select the arc and arrange in a ascending order. Suppose that minimum value, edges, weight and selection, okay. Minimum weight for value edges is ED, then 5 EA, BC 5, then AD, then BD 6 and AB 7 and CD 8, okay. 4, 5, 5, 6, 6, 7, 8. These are weight of arc. Again we will select ED, have the 4 weight, then here we will select ED, okay. Then again ED, weight 4. Again EA, select EA, then wait 5. Then select BC, value 5. But if you select the AD, then here circuit will be create. That's why we will not consider. Okay, that's why we will not consider. Next means it will be not considered. Then BD 6. Then we will select the BD. It's have the 6 value. Through the BD, we will not create any circuit. Then AB. If we create a AB, then circuit will be create. That's why we will now select the AB. Then CD. If you select the CD, then circuit will be create. Okay. So here we will consider only 4 edges: ED, EA, BC and BD. Calculate these. 4, 5, 5, 14 plus 6, 20. Means value is 20. Okay. Any confusion? So here algo is already present. Sort all the arcs into ascending order of the weight. Select the arc of the least weight to start the tree. Consider the next arc of the least weight. It would form a cycle with the arcs already selected. Reject it. If it does not form a cycle, then it to the tree. If there is a choice of equal arc, then consider each in turn. And then repeat step 3 until all vertices are connected. Any confusion? But before the Prim's algorithm, here this is the new topic, new question. KRUSKAL algorithm to find the minimum spanning tree for the below network. This is the network there, or we can say that this is the graph. Okay. This is the graph. Then again we will select the all arc into ascending order. Here BC, IJ, GI, GCG, BE, CD, KL, EF, AB, 6, AD. Then here BC is a 1. Then BC is a 1. IJ is also 1. Then GI. Then we have the value GI is also 2. Then CG also 2. Then BE. Then BE also having the value 2. Similar way we will arrange all arc in ascending order. Okay. Then again start from the BC. BC having the 1 value, then B to C, this is the 1. Then again IJ also have the 1 value. Next GI also have the 2 values. Then BE also have the 2 values. CD also have the 2 values. Then KL also have the 3 value. Then EF also 4 values. Then A6. Here A6 is an option. If you want to consider A6, then you will take. If you want to not consider, then left it. Then AC, or you will consider also AC. If you want to consider AC, then this is also welcome. Next, EC6. If you consider EC, then EC also create a circuit cycle, so it will be not considered. Next, JL8, we will consider it. Then FH also 10, then we will consider it. If you want to add all things, then what is the calculation? 8, 3, 1, 2, 2, 1, 2, 4, 10 and 6. Then value is 41. Then value is 41, means total weight is 41. Next, these types of question also present in a university exam. So this is a question. If you have some time, then solve it in your home. Okay. This is a technique. So here same technique will be apply here. If you want to solve this, then this is the procedure and you will be solved. Okay. Next topic, Prim's algorithm. A Prim's algorithm is provide a similar resultant, a similar way, but something is different, because in a KRUSKAL algorithm we will work on the arc or edges, but here we will work on the vertices. Maybe question will be arises, who is better, Prim's or a KRUSKAL? Then Prim's will be better in compare of KRUSKAL, because it's a fastest algorithm and work on the vertices. That's why it will be best. Why might you use one rather than the other? Then to use the KRUSKAL, you have to sort all the edges into order first. This could be time consuming. Okay. First we will arrange the in a increasing order, then we will be considered. But if you choose a KRUSKAL Prim's algorithm, then ascending or ascending order sorting no matter. Okay, we will include only vertices and added the value of the arc, means weight of the arc, and and we will get the fastest resultant. Okay. Then Prim's may be faster unless the edges are already shorted. Prim's is usually faster if you have a graph with high ratio of edge to the vertices. What is the main difference between Prim's and KRUSKAL algorithm? Prim's algorithm will be work on the behalf of vertices, and KRUSKAL algorithm will be work on the behalf of arc weight. Here Prim's consider vertices, whereas KRUSKAL consider edges. Okay. And this is the algorithm. It's however only 3 lines algorithm. Choose any vertex to start the tree. Select an arc of least weight that join a vertex that is already in the tree to a vertex that is not yet in the tree. If there is a choice of arc is equal weights, choose randomly. Third point, repeat step 2 until the vertices are connected. This is the question. This is the graph. Choose any vertex to start the tree. If you want to start a tree, then we will choose any vertex. select an arc of least weight that join a vertex that is already in the tree to a vertex that is not at in the tree. If there is a choice of arc of equal weight, choose randomly. Okay. Repeat step 2 until all the vertices are connected. We will start the vertex A. First, add AE, then here we will declare AE, then add ED, ED4, then here ED, then add DB, then value of the DB is 6, then add the BC 5, then find the value of 5, then 5, 4, 6, 5 is the total 20 weight, then we will get the minimum spanning tree's weight is 20. Okay, means suppose that this is a tree, this is a graph, then here we will start from A to E we will get the 5 weight, then A to E total weight is 5, then E to D we will get the total weight 5 plus 4 means 9, then 9 plus 6 VD it's a 15, then 15 plus 5 is equals to 20. Okay, this is the resultant. Next, this is the graph and here we will find the network. Okay. Again, this is the A, B, C, D, E, F, G, H. Different types of arcs is also available. Then again, we will start from BC. We will take the examples through the BC. Okay. Then here is the arc is phi B. Then this is the BC. Weight is 1. Okay. Then again 2. Then again 3. Then again 1, 2. Then JL. Then again 2, 8, 2, 6, 2, 4, 10. 10 plus 4 plus 2, then this is the solution. Okay, same procedure will we apply here. This is a question. This is a question. If you want to solve this question, then examples: Prims start with any vertex. KRUSKAL start with the shortest arc. It is not necessary to check for cycle when using a Prims. Prims adds needs to the growth tree. KRUSKAL adds arc. The tree grows in a connected fashion using the Prims. Prims can be used when data in a matrix form. Other character statement also get the credit. Then second thing, these types of also a question are also present here. Start two differences between KRUSKAL algorithm and Prim's algorithm for finding a spanning tree. And main thing is KRUSKAL work on the behalf of arc weight, and Prim's also work on the vertices. Okay, these are some types of algorithm. These are also available. Method will be same. Thank you very much.